All right, this is the remainder of DES. It's very short and very dark since we have no projector on. Hold on. Turn the projector on.
I see images. Oh, like that's in my head.
What's in your head?
Oh, yeah.
Is it lit up?
Look, you're still red. No, it's still red.
Come on.
There it is.
Okay. In a moment here, we'll have an image on the screen. Yes, I heard the magic beep. We do have a green line still. This camera refuses to fix. I don't know what's up with that.
You know, this, I'm not maintenance. Call maintenance. Tell them to switch it over.
Yeah.
There's that.
Okay.
That's my head.
Yeah, we're wet.
So this is DES Part 2. Probably could have covered it last time, but oh well. No assignment based on this since you already have an assignment on DES. So. All right. So DES.
Recording.
Yes, I'm recording. Actually, let's make sure I'm recording. Yes, I'm recording. Okay. DES, Data Encryption Standard. This is originally submitted the Lucifer algorithm in 1974. Okay. It says original algorithm used 48 to 128-bit key. So in other words, they had a variable key length. They came up with 64-bit key version, which is 56 plus true 8 bits for parity. Okay. And we have to tell it to keep this every time. It was altered to become DEA, not Drug Enforcement Agency, but Data Encryption Algorithm. Okay? Then, this is determined need to protect sensitive data. And that was funny. The next algorithm we're going to, well, soon I'm going to be talking about the one that begins with the letter A. Okay? I spoke somewhere, and I mentioned how it could be used to secure data that starts with T and S. Suppose we can't put those together. Did you know that? You can't say the algorithm names and the T and the S in the same thing. Because I said that, and some guy after the lecture says, you cannot mention them together.
Why?
It's my point exactly. Why? This guy used to work at the NSA. Says, you cannot say that. Okay, I won't mention them together. I don't know why.
So you do it on purpose now?
No, I didn't. I didn't put those together. A's a letter. Before B. Okay, but they needed something to protect data in the 60s and 70s. And you know, back in the 60s, that's when I was born. Anyone else born around then? 62. Wasn't really interested in computer encryption at that point. I was thinking more like dirt, dump trucks, Legos, you know. But they needed something in the early 70s. Okay? It says the invited vendors to submit techniques, and IBM was actually submitted. Okay? They had been developing stuff already. If you read that book, Crypto, it talks all about this. It's really interesting.
By the way, if anybody wants one, I've got an extra one.
Okay. If you want to read it, it's really, it's a story. It is. It's easy to read. It's really tells you a lot about this, and I recommend reading it. Okay, so in 1974, IBM submitted the Lucifer algorithm, and it was accepted. Okay. Okay, there's this controversy over that it was weakened. Again, was it or not? I don't know the true story, but I would think it is. I think it has been. Some people say it's because the NSA couldn't break it. I don't know. Okay. But there is controversy over that. Okay. Became the standard in 1977 and the ANSI standard in 1978. So everybody started using it. Okay. Nowadays, with stuff changing so quickly, I'm really surprised it lasted as long as it did. Okay. Was implemented many ways, and it's actually still used today. You can still, there's a lot of firewalls out there that use triple DES, which is a variation of DES, which we'll talk about. But yeah, it's still being used. It's still a viable standard. It's not like web that breaks in 4 seconds. So it's still a viable standard. Just, you know, it was tested and approved as the strongest and best one on the market. At the time it was. Okay. But there were some problems with it. Okay. We'll talk more about that. But this is basically a block symmetric algorithm. Symmetric is same key. It's block. We do it based on blocks. So blocks are 64 bits through 16 rounds of transposition and substitution. Okay, we don't really know why, like the S boxes did it the way they did it. Why? We don't know that. Okay, order and type of functions are dictated by the key value. Remember, the key shifts once, then it shifts twice, then it shifts once. So, all right. And for government agencies, used to protect sensitive by unclassified data. They won't say it was used for top secret data, which I don't know if it is or not. All right. The different block modes. There's one test question over what we covered so far, but there's a test question over the block modes. So you need to know the different block modes. Okay. First one's called the electronic code book. Okay. So it's the same ciphertext is always produced from the same plain text. So if I give you the same plain text, run it through ECB, you get the same plain ciphertext. So same cipher, same plain gives you same cipher when using ECB. Okay, it's very easy to identify patterns this way. Right? It's best for small amounts of data. You don't want large. Okay, and it says the key indicates the different code books it used. Okay? And it uses method authentication code, okay, for verification and integrity. Here's how it works. We take our plain text into our algorithm with the key, and we get the ciphertext. So this, again, if we took the same plain text each time, we would end up with the same ciphertext each time. Y'all agree with that? They're not chained in any way. So if I put the same, if I encrypted, can, we always get the same results. Okay, so that's what ECB is. Okay, now let's talk about cipher block chaining. There's a big difference here. Now, encryption is dependent on values from the previous blocks. We're actually going to be chaining them together now. Okay. Oh, I was like, why is it? I'm hitting the wrong button. Sorry about that. Okay, says we encrypt 64-bit. Every semester I mean to fix that, but I keep forgetting. Encrypt 64-bit or bit blocks, but chains them together using XOR. We know what XOR is. One or the other, but not both. Okay. So XOR was cipher block from the prior block. Then the streams are more randomized, and it does not show patterns. Let's look at a picture of that. So I take our initial plain text. I XOR it with some initial value. Okay. Then I encrypt it. That gives me ciphertext. Okay. Then I take that ciphertext right here. I take this first ciphertext, ciphertext 1, okay? Then that gets XORed with my next plain text. So even if I encrypted can, it will be different because the results of the first ciphertext is actually used as the vector for the second one. You see that? Because this first ciphertext down here gets brought up and XORed. Remember, we initially XORed with this initialization vector. Now the first ciphertext is used. Then the second ciphertext becomes this next one, so on and so forth. So they're chained together. So even if we had the same plain text, now we would end up with different results every time. Is it better? What do you think? Definitely. You do not want patterns. The whole point of cryptography, you don't want somebody to be able to look at it and determine what the results are going to be. You want it random. Okay. And then decrypting was at the bottom there. Okay. Very short and sweet. You do need to know these two block modes. Okay. So the two you got to worry about. We cover a little bit more about them next time. Could cover no, I don't want to cover the next one yet. That'll throw out the schedule. Any questions on ECB or CBC? Okay. I've never come up with a homework assignment for this. Sorry about that.
Oh gosh, don't.
I know. You only get 9. In the past, prior to this semester, I actually had an additional assignment in there. So if you see reference somewhere to a matching assignment, it's no longer there. So you can disregard it. But it's... People complained a lot. It was just... So, all right. So we're done with DES at this point. And actually, let me look at the schedule here because I got it right here real quick. I think is it not in here? Hold on. Let me log into our class here. Actually, I can log in real quick. Actually, let me pause this recording in case. All right. So here we are. This was Lecture 10, DES Part 2, and we actually have fall break next week. Okay. It shouldn't affect you guys because it's really only Thursday and Friday, but I'm not having class on Tuesday. So in other words, no class next week. I know you're depressed. Then we'll pick up on the 20th. And wait, I thought did I not put it in here with the third other test? Darn it. You guys only get 2 tests. No, you get, that's there. Okay. I was freaking out there for a second. I thought I missed a test. Yeah, you get 3 tests. So. Okay, but we have fall break this week. See, fall break is actually it's the 16th and 17th, and then the 11th through the 28th. I know, it's weird. But we'll pick up again on the 20th, which is the week after next. And that's where we're going to cover a little bit more about the different block modes plus triple des and stuff like that. Okay. And then we have 2 more algorithms before the next test. Then you'll notice down here we have Diffie-Hellman, assurance, and digital signatures, but there's really only 1 assignment. Okay, so you only got 3 more assignments. This assignment's very long, and you'll notice that I actually give it to you on the 3rd, but it's not due until the 23rd. So you get 3 weeks, basically. You're going to need it.
I was going to ask you, does that mean it's probably going to require
What I did was, in the past, with AES, I tell you how it all works, and then I give you a worksheet that's partially filled out. You just have to fill in the blanks. But everybody used the same worksheet. So literally, Cameron could do it and pass it around to everybody in the class. Well, it'll no longer work that way. That worksheet is now the practice assignment, fully filled in with all the answers. So now you have an entirely blank one that's based on your name. So unless you happen to be in a class with another Marlene Moore, you're getting your... You are literally going to be doing this one by yourself. Okay?
Is she enrolled in your classes?
But since there's more blocks to do, each block is literally worth less points. So you can get more wrong and still end up with a decent score. You understand what I'm saying? Before there was 84 blocks, now there's 115 blocks. But, you know, it's still only worth 100 points. It's not like you're getting extra points for it. But the assignment is actually up there already. If you want to start looking at AES, that way you could ask intelligent questions when we're going over it. I'm telling you, a lot of people have an issue with AES. They're like freaking out over it. So it's not that big a deal. But yeah, your RSA is simple. It's literally it's just simple. It's all there is to it. Then we got AES. See, we've actually done a lot of lectures. I just chopped a whole bunch of them at the beginning so we could get material covered. Then we kind of cover stuff at the end. But, you know, AES is really the only thing hard that's left. But there is test questions out of each one. Okay? So any questions about DES? We're totally done with it now. I'm never going to mention it again until you take a test. What? No class next Tuesday. We will have a lecture the following week, but no assignment for it. So really, the next lecture with an assignment is actually on the 27th. This is with RSA. Okay? Everybody happy? All right, let me stop this.